everyone. My name is Francis Han, and I'll be talking about the various perspectives of the smart cities. I believe last week, some of you may have attended a preview of the use cases for smart cities. And today I'm going to spend about an hour or so to go through some detailed perspectives of it. And today I realized that the bandwidth is a bit lagging. So do bear with us in terms of the speed. I think now it's a bit faster. All right, many a times we come across websites that require us to do things like, turning animals around and selecting pictures containing some objects, and do certain things to prove that we are not robots. Now, this is because machines have become very adept at performing certain human tasks really well, and even better than us in some cases. So they could create, fake accounts, and they could disseminate fake news, and even book all the badminton courts and put them up for sale on carousel. Right, and so the line between machines and human has been blurred over the years. Today, humans are may be required to prove that we are not machines. In the future, machines may be required to solve complex puzzles to prove that they are not humans, that they are not susceptible to making mistakes, etc. Right, so we are not there yet. But let's see, how we have arrived at where we are today. So back in 1896, at that point in time, I think that at that point in time, the greatest invention was, the steam engine and electricity, right? Nothing, about computers, and so even in the Olympics in Athens, 1896, nobody knew, what sort of spring start position to adopt, for a race like this. So you can see you have how many runners, this 5 runners here, all right? They all adopted different pose before the race, right? And you notice that the second the second runner from the left, he adopted this unique position or unique pose, right? And strange enough, right, he won the race. And so after that, for all athletes who are preparing to run a race, that is the gold standard pose to adopt. In the same way, you look at technology, right? It took some time for technology, to come to a stage that we see today. So over the last few decades, you see, in terms of computer technology, a few things came together, and the so-called the stars are aligned in terms of the clock speed, in terms of the transistor density, the internet connection speed, as well as algorithms were getting more and more advanced. So all this came together, and put us in a better place today, and to be able to harness, to leverage technology to solve complex problems. And over the years, cities around the world have been facing problems related to pollution, to sustainability of water and energy supplies, to traffic accidents, and natural disasters, and many others. And every year, the number of people dying from air pollution globally stands at around 7 million. Death from road accidents is about 1.3 million. And unsafe water claims about 1.2 million lives globally every year. So nations have, begun to collect, to analyze data pertaining to air, water pollution, and have taken steps to address them. Alternative sources of water and energy have been incorporated into the ecosystems, and we are able to manage the flow, the quality, the consumption, etc. So, I was driving um, uh, in Singapore one day, and I stopped at the traffic light, and so I turned to my right. I saw this structure with 8 cameras on it, as you can see on the screen. So I snapped a picture of it, right? So in terms of security, safety, etc., cities around the world have been adopting, cameras on the streets, right? And so this is also some, recent development, and you can see, the all the major capitals around the world, with increasing number of cameras, etc., right? So that is, a global phenomenon. And I can't help but think of the myriad possibilities, from the video images of the surrounding that you can get into, right? And we so in terms of bringing down the fatalities on the roads, some countries have begun, testing autonomous vehicles, and we are not at a stage to be able to do away with the steering wheel completely just yet. If you step into any of the self-driving car today, you'll very likely see a steering wheel in it, right? Because we are not there yet to be fully autonomous. We are not at level 5 yet, right? Most of the cars are level 3, level 4, right? But at this moment, most, if not all, the autonomous vehicles are able to do, some of the key functions like route planning, collision avoidance really well, right? And millions of miles of traffic data, have been used to train the deep learning algorithms for these vehicles. And if you look at, one of this self-driving car, you can see that there are a lot of sensors, much more than a typical human. I mean, a human being, right? We have our regular, sensors, the sight, the hearing, the smell, and so on. But if you look at an autonomous vehicle, you have the lidars, the radars, the cameras, the ultrasound, the IMU, the infrared, and many of them all clustered around the car. And it allows, all these sensors allow the car to be able to navigate in low light, in bad weather, in very adverse conditions, unlike a human being, right? And it serves as a means to reduce human errors on the roads and to bring down the fatalities and accidents. So there are many factors that come into play, right, to make a smart city successful, right? And technology is just one of the pillars. And you have things like stakeholders, very important, because you need stakeholders to champion the smart city, to come together, to have the policies and regulations to drive it. And funding is a super important pillar as well, right? And also strategy. You need, if you look at, some of those smart cities out there that have been functioning, and those which are functioning well, typically you see a strategy that is, working along with it. A strategy means that you need to set, your goals, your long-term goals, your short-term goals, and you have some KPIs to measure, and so that is actually, if you look at strategy, funding, stakeholders, and so on, those are very big pillars to get into. But today we're going to focus only on technology piece. And this is what this hackathon is all about, right, for now. So, some decades back, mankind has already started to leverage technology, to make our cities smarter. So back in, the 60s in Los Angeles, the city council formed what we call the Community Analysis Bureau. It's an agency called a CAB, Community Analysis Bureau, and they started to use technology to try to do good things for the city, right? They use computer databases, gathered data from the various other agencies, and they do things like aerial photography. At that time, there are no drones yet, right? So they have aeroplanes and taking pictures from the sky, etc. So with the data, they were able to perform cluster analysis and produce reports on neighborhood demographics and housing quality, and help direct resources, right, to do things like warding off diseases, in the communities, and to tackle poverty, right. So the aerial photography was mainly used to analyze the more than 1 million housing sprawled across 500 square miles, and this enabled them to locate those housing in dire need of repair, right. And based on the information gathered, they were able to make good recommendations on the various aspects of urban renewal, right. So this was a really good start, for the city authority to improve the living condition of the citizens. And for the city of San Jose, recently the CIO of the city council in San Jose gave a talk about their smart city journey, for which they deployed the Oracle solution. So San Jose, which has a population of just over 1 million, wanted a solution to help the city council engage better with the citizens. And they implemented a mobile-based system that enables the citizens to report problems like street lights not working, or there are potholes on the roads, illegal dumping, abandoned vehicles, which were quite common, in certain areas. And a city council employee will be able to view the request or the complaint from the citizen and be able to channel it to the right work team to sort it out, right? And the particular request is subsequently updated as the work is getting done. And the system helps to link the city council call center with the various stakeholders and citizens, and to tackle the issues that the city is facing. So that helps to streamline and make things more efficient for them. And there's a government agency in Malaysia who needed a system to help them cope with a high volume of complaints. So this agency takes in complaints from the citizens, right? So what happened was that they deployed our Oracle Cloud solution to channel the complaints via the WhatsApp channel, via the Oracle Digital Assistant, as you can see on the screen over here. And the complaints are segregated into the different categories and aggregated according to the issues, and stored in the Oracle Autonomous Database. And then using the Oracle Analytics, agency staff can review and rectify the specific issues rather than go into each and every complaint, right, to deal with them. So this brings about a lot of efficiency as well, and cut down the time, for this agency staff, right, to deal with the complaints. Now it's getting slower, this latency. Okay, all right. And in Warsaw, Poland, there was a project to implement smart street lightings, smart waste bins, smart parking, etc. Right, and also to monitor the air quality in various locations, and that is where the Oracle solution can work with the different sensors out there, sensors in the environment, and to do some sense making and to do some logic and decisions around this the information that's gathered, right? Um, and that's where the Oracle's spatial analytics come into play as well, together with the database, machine learning, and other components. And so I'm trying to get this yeah, okay. So it takes a while for this video to be playing. I'm not sure why. Give me a second, let me see. Okay, all right, I think that's okay. Yeah, so there's a customer called AgroScout, right, who deployed their solution on the Oracle Cloud, right, to help them to improve the what we call the agriculture yield, right? In a factory, you have the factory yield. On a farm, you also want to have yield as well, to have as high a yield as possible. So you cut down, the problems, coming from crop diseases and whatsoever. So this customer deployed the Oracle Cloud technology, right? So that they can analyze the images and look out for anomalies, and then be able to pinpoint the location of those problems and to deploy their resources to rectify them. Right? So I can see that the on my second screen the video is quite laggy, but it's okay. Let me just move forward. So let's look at the advancement of some key AI technologies that we have today. Back in 1805, right? We have this what we call machine learning algorithm, right? At that time, it's not called machine learning anyway, but we have this thing called a linear regression, right? It's not rocket science, but it more or less is a start, to this whole journey of the machine learning evolution, where we are seeing a lot more and much more complex algorithms. And then, so linear regression serves to ascertain the relationship between two variables, right? Independent variable and dependent variable. And it can be used, by, let's say, car insurance companies to come up with a premium table to charge the customers. So the risk can be assessed, based on the attributes of the car, and as well as the driver. How fast is the car, and how many years of driving experience the driver has. And with that, they can ascertain, okay, what sort of premium this driver should pay, right? That kind of thing. So that's the premium table, right? So linear regression can be used for that. Has been used by insurance companies for that. And as the name implies, it models the regression, of the continuous dependent variable. And we also have the logistic regression that does the binary classification, right, to predict pass or fail, right, true or false, that kind of thing, and to predict the risk of, let's say, developing various diseases, and also to be used in so many other applications. And then we have what we call the SVM, right, the support vector machine, right, that help us to find the best margin. That is the distance between the line and the support vectors, right, between different classes of data points. And then you have the very popular decision trees, which is a way of modeling, based on conditional control statements. that's the reason why decision tree is so popular, because it sort of mimic the language more so than the math, right? It allows you to see things from language perspective as well. And decision trees are very flexible, easy to understand, easy to debug, etc. So whereas naive Bayes algorithm, that is based on the Bayes theorem, and is typically used when you have high dimensionality, etc. And some I saw some journals doing comparison between naive Bayes versus other algorithms and so on, and quite often I see that naive Bayes is featuring quite well. And then you have the neural network, right, on the that is highlighted in green on this screen, which is a different species altogether, and it's about brute force recognition in my as far as I'm concerned, right? Very brute force, and so recognition on a data set which could be of any dimension, and it forms the backbone of deep learning, right? Where techniques like computer vision, natural language processing rely heavily on. And in the early 90s, I'm sure you may have heard of this competition called ImageNet competition, right? So sometimes when you look at stars, before they become celebrities, they join certain competitions, become famous. So ImageNet is like that, right? It's for those people who join the competition and they win first prize, and they become rich and famous overnight. So back in the early 90s, that this guy called Yang LeCun, who submitted his work, what he called the LeNet architecture, to do image recognition. He won the competition, and after that he became super famous. And a lot of algorithms, the convolutional neural network, have evolved, and many of variants of it since then. And accuracy of this computer vision has become a lot more accurate over the years. So when you look at AI is like there are many specialties in AI, and you ask 100 people what AI is, they probably will tell you quite different stories about AI. So the way I look at it, I classify AI into a few areas, right? The machine learning, the computer vision, the deep learning, the robotics, the natural language processing, etc. So in machine learning, I look at things like supervised learning, unsupervised learning, reinforcement learning. These are the main things, right, under the machine learning. And for supervised learning, suppose you are told to look for gemstones and coins which are lying at the bottom of a river, and you are trained to tell that the features of a coin that is flat, is round, etc. Those are the features of a coin, and you're trained to do the same for the gemstones. Then you go in the river and begin collecting and sorting out the gemstones and the coins, and they come out of the river with a haul, and someone go through it and tell you how accurate your sorting has been. So that's supervised learning. And for unsupervised learning, suppose you go from the river to a very deep ocean, and you don't know what species of fish to expect in that depth of the ocean. And then one school of fish comes along, and you note that this group has a certain set of unique features, maybe 3 eyes, 5 fins, 2 tails, whatever, right? And you classify this as group 1. And then next group of fish swims along, and they have different sets of features compared to group 1. Maybe they have 10 eyes and no fin, etc. Right? And you classify this as group 2, etc. Right? And then you spot one lone fish swimming alone, and then you could tell that this belongs to group 1, okay, based on the features that you see. Right? So this is unsupervised learning, right? And reinforcement learning is about having a reward system for an agent to take actions, right? Going from a state to another state to another state, etc. Right? In an environment, and the whole idea is to try to balance between exploration and exploitation, right? So that you can get the highest possible optimum value at the end, right? So that's reinforcement learning. And then computer vision, is something that I talked about earlier, right? The convolutional neural network, and you have so many other algorithms today which are working very well for computer vision, right? And accuracy is super good, and things like that. And so that's to me, one of the greatest breakthroughs as far as AI is concerned. Having very accurate computer vision capability to be able to solve a lot of problems today, right? And as far as smart city is concerned, this is a very, very important pillar for this area of technology, right? And then deep learning, if you look at it, right, is actually, to me, is a very important pillar that helps to power the computer vision and the natural language processing, right? That is one of the key reasons why the accuracy for computer vision is so accurate today. And also the same thing for natural language processing, right? The moment this deep learning took off, right, with very high accuracy and etc., you can see that the natural language processing accuracy has also shot up, right? That's the reason of the accuracy going up for NLP. And then robotics is an amalgamation of all these different technologies coming together, right? On the robots itself, I'll talk a bit more along the way. And to me, smart city is about solving, all the different problems, right, that goes between the device and the user touch point. So your user touch point, typically is a screen for you to look at what's happening, take action, etc. And the device can be, a camera, it can be a sensor, actuator, whatsoever out there. And in between the device and the user touch point, Oracle has the whole spectrum of solutions to be able to solve the various set of problems, right? As you can see on the screen. And even before the device itself, we can, perform things like device management. We can, manage, all the different devices out there, manage all the data that coming from each device, right? And to do things like simulation, digital twin, etc., right? Before even going to the actual device itself. And Oracle is much more than a database company. It can do a lot of things, as you can see over here. It can do data preparation, feature engineering. It can help you to train, right, your algorithm, to test, to validate, and to also deploy the algorithms to classify, and to do predictions, etc., right, to process information and put in your Python codes, Java codes, etc., to do the necessary processing and take actions, etc. And to be able to work, between the cloud and the edge, and vice versa, and also to aggregate and store, the information in your database. For us, we have this best-in-class database called autonomous database, and also to be able to share, what we call share this information with what we call the open data, which is something that you hear about a lot nowadays, and we have this blockchain technology that allows you to do that very well. And then we have the technology to allow for machine-human interaction, the NLP, NLU, the chatbot, and all those different areas of technology that come into play, right, to bridge the gap between the machine and human, and also the analytics, right, to allow you to look at things from the map perspective, spatial, from the graph perspective, from the chart perspective, from any perspective, right? So if you look at it, we have that full spectrum of solutions that allow you to deploy a solution to solve very complex problems. So this is another perspective of it, right? And when you look at smart cities, you talk to different people, they tell you different things about smart city, right? The requirements for smart cities, they are all very unique, all very different. So the key thing is, what sort of problems you're trying to solve, right? That is always the key thing about smart city, right? And how can you solve this problem, right? So you identify the use cases which could be, deployed to solve those problems. And then you analyze, what sort of data you need to collect, right? And how to process it, what algorithms to use, etc. And then, how do you deploy the solution? And that's not the end of it. You still need to look at ways to improve the solution and, go through this feedback loop, as you can see on the screen, right? To make sure that this solution is sustainable, is able to solve the problem, not just right now, but for the foreseeable future as well. And behind that, I mentioned that we have the whole spectrum of technology coming from Oracle, right, to be deployed to solve all these problems. So you can see, right in the middle, we have the autonomous database and blockchain, the big data analytics, the chatbot, and whatsoever. So so that's something that that Oracle has in terms of the possible solutions that are capable to help to solve the different problems out there. We don't necessarily have to deploy everything to solve every single problem, but it depends on the nature of problem and for case by case, what sort of solution components are required for each case and so on. So from a use case perspective, I believe all of you may have heard of the different use cases, and you understand that there are many use cases out there, right? For the energy use case, for the water use case, etc. Typically energy, water, those are the sustainability use cases where you are dealing with renewable energy. You need to be able to deal with distributed energy resources, whether it's solar, wind, etc. Right, and have a microgrid, kind of capability, such that you have a small network of this energy sources and consumers and whatsoever. And then as far as energy is concerned, one of the use cases that you may have come across are things like smart street lighting, right, to help to minimize or reduce the energy consumption. And then for water, which is also equally, if not more precious resource, right? It is. Not too long ago, I was talking to a customer who is using alternative water sources, and not buying the water from the utility company, but taking water from the rain, from the storm, from a river, etc., and putting this water through treatment, and then to distribute it, to the consumers, to their tenants, right? So things like this are happening, right? And for that to happen, then you need to bring in the sensors, you need to bring in algorithms to check the quality, the level, the whatsoever, and then to do metering, the billing, etc. So those are things happening as well. And then you have transportation, right? I mentioned a bit about transportation in the beginning, in terms of trying to drive down the fatality rates and to make our transportation system a bit more efficient, right? In terms of the traffic lighting and the parking and so on. Parking is one area. It's not just parking itself, because you also want to make sure that drivers don't drive around too much, right? Sometimes you have to drive in circles looking for lots, and doing that, driving in circles, add to the congestion, right? And also to the frustration of the drivers as well. And then you have the smart policing, which is, I talk a bit about that as well. 8 cameras on one structure, right? So you have things like smart policing, and you have the need to monitor, certain person of interest, that kind of thing, and then to help to drive down the level of crime in a city, etc. And some countries are quite focused on managing the disasters, also depending on the locality of a certain city and or certain region that the country is in. So things like flood management, landslides, landslide monitoring, etc. And you also have the need to be able to monitor pollutions, and I think that happens almost everywhere, right? We have sensors to be able to monitor the pollution level, right, in the air, in the water, etc. And then you have waste management, which is a big thing as well. As far as cities are concerned, waste management is always one of the topics of discussion for the city authorities and for this for use cases to be able to deal with some of these problems. And then we have the different other areas of use cases, which I'll not go through over here, but I think there are a lot more. And I think you may come across a lot more use cases that I may not talk about in this session. So this is one of the example use cases. Let me just drink some water first. So this is one of the example use cases which I'll talk about. So this is the smart parking. We put together some intelligent use cases using AI algorithm, and this is one of them. There's a smart parking. In this case, the data is actually the data is actually the running video images, right, of the car park. As you can see from the video over here on the screen, you have a camera and you have the car park, and the car is going in and out of the lot, right? You can see there's a big screen at the back of the video. So the big screen behind has got 3 segments, the left bottom segment and then the right segment. Left bottom segment is the processed video coming from the camera. I say process because you can see there are green and red rectangles on each parking lot. Now on the right of the big screen at the back is the dashboard that shows you each lot, whether they are green, that's vacant, or they are red, is taken, right? So the second lot is toggling between green and red, etc. Right? So what's happening here is that the camera takes in what's happening in the environment. The environment is the car park, right? And you have 7 lots on the car park, and then and the camera is able to take in this environment, and then this video from the camera goes into the algorithm, which will process the image, image by image. So depending on how many FPS you're dealing with, right? So and some are discarded. So for each image that it goes into the algorithm, you can count the number of lots that are vacant. So that's how you ascertain what is the lot availability for the car park, right? So this information, the numerical information, is sent to the cloud, right? So you can see, edge computing going on, right? Process a video, and then you find out what is the number of lots available for the car park and which lot, and send this information numerical to the cloud, to the Oracle Autonomous database, store it in the database, and then from the database it updates the dashboard. The dashboard shows you that you have 6 lots available or 5 lots available, depending on which point you are looking at it. So let me just, so as on the right of this screen, you can see the red car, the driver driving it, and the driver can do a query with the system to ask where can I park my car? Or maybe where can I park my electric car, right? So the system will be able to tell the driver, okay, you'll drive 100 meters on the left is a car park, which lot you can park, right? Things like that. So this is one camera, one car park. You can have multiple car parks. You can have so many car parks in the area, and the system can manage all these different car parks and be able to direct drivers to the nearest car park, to the nearest, the most convenient lot, and to the lot that's suitable for the car that the driver is driving, etc. And this is another perspective of the use case, whereby you have the car park and you have the lot detection that's going on. The camera is overlooking the car park and processing the video and then ascertaining how many lots are available, which lot, etc. Send this numerical information to the cloud to update the database, and database update the dashboards and update the digital assistant, as you can see over here. So that allows the machine and the human to be interacting, right, with each other. So that's one example. So let me go to the next example here. And so another use case is based again on the computer vision and AI algorithm, and this is the flood control system, right? And the camera is directed at the canal bank to determine the water level, right? So water level is collected together with other parameters, right? And then so as you can see on the screen, now actually the camera is hidden. The camera is embedded in this residential block over here, and then the camera is overlooking the canal, the simulated canal bank, and the camera will process the video with the help of the algorithm, and then so it's able to ascertain what is the water level in the canal bank. And then so the on the big screen, as you can see on over here, you can see that water level is going from 0 to 1, and then it goes to 2, etc. Right? So we can gauge what is the water level in the canal bank. Right? And apart from the water level, you can collect other parameters like rate of water level rising, and what is the rainfall in that particular location. And so using all these input parameters, you can do you can bring in an algorithm, right, to process it and to do prediction, right? So in this example, you have a whole set of supervised learning algorithm to choose from, right? And to do the flood probability. And then with that, you can take the necessary action. Right? Let me give you a different perspective of this. So from this diagram, you can see that we are, for simplicity, we have these 3 parameters as shown over here: water level, rate water level rising, the rainfall, and these 3 parameters go into the naive-based algorithm, and then out from the algorithm is the prediction probability. And when you have a certain level of probability, or you have a prediction that flood is going to happen, then you inform the respective agencies, and the agencies inform the drivers, activate the siren, etc. And then you may take actions like to move the floodgates, etc. So this is the perspective coming from the solution architecture. Another use case, we have this smart street lighting, which I mentioned a bit earlier. And we use the object detection, right, to turn on the street lights only when when we sense a presence, right, in that location. And the use case serves to, in this use case, the objective is to help to save electricity. So in some cities, right, we see the possibility that the energy saving could be up to 50%, right, with this smart street lighting deployed. And what's happening is that when I look at smart street lighting use cases in many cities around the world, city authorities tend to bring together a few use cases onto that one single lamppost, right? Because you can mount the camera on the lamppost and to take in what is happening in the environment, whether you have presence of people, car, and so on. As a result, you turn on the lights or you dim the lights, etc. And because you have already a camera on a lamppost, you can use the camera to do other things. You can recognize, pedestrians. You can look out for PMDs on the roads, see whether there are any PMDs, and take picture of them and go after them, etc. Or you can check on the speed of vehicles, and you can look out for accidents in that area, or you can look out for maybe there's a crowd and you want to do crowd control whatsoever. So there are various possibilities, right, in terms of the same setup, right, to do multiple use cases. And then next one, we have the smart traffic light. So in the smart traffic light, as you can see from this example here, right, you're using the camera to assess the traffic situation and the presence of pedestrians. The algorithm will be able to make use of this information to determine when to change the traffic and the pedestrian lighting. So this will help to reduce the waiting time for the vehicles as well as the pedestrians. And the system can also look out for emergency vehicles, VVIP vehicles, or accidents in the area, and do something about regarding timing. And next one, we have the person of interest use case, where the camera is able to pick up faces among a crowd, and they are able to recognize them, multiple faces, whether they belong to a group of wanted criminals and terrorists, etc. And to support this use case, we have deep learning algorithms, and we could run them, train them on our OCI GPU, etc. And this one is intruder detection, works roughly along the same line, but we have the background subtraction algorithm to look out for intruders before this face recognition algorithm kicks in. I'm just looking at the time, and so I'll speed up a bit. And then we have computer vision is actually one of the important areas, as I mentioned before, and there are algorithms that deal with it. And so there is something that I talked about before, so I'll skip this. And so I just want to mention this in passing. One of the coolest algorithms, that's a GAN, right? Generative adversarial network. And there are some use cases that go along with this GAN. You can generate the faces from scratch. You can generate a painting, generate an article, etc. Right? And so I can see that okay, the slide is transitioning. So machine learning is one of um, the, 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 the reasons why smart cities are getting smarter. And I believe many of you are, have come across the things like anomaly detection, right? So some of the use cases that have got anomaly detection would be things like, let's say you deploy the algorithm in a train or on the train tracks, and you can detect the vibration, and then use the anomaly detection to look out for anything unusual, whether there's something wrong with the train, something wrong with the train tracks, and then get the maintenance crew to work on specific issues, at those locations that you detect any anomalies. And then for classifications, there are many algorithms that can do that. And you have, different types of classifications that you can do. You can do multi-class, or you can do multi-labels. And I believe you know what's the difference between multi-class and multi-labels, right? But to give you some examples, let's say you have a group of athletes, and so there are different ways to classify the athletes, right? You have the male and the female athletes. That's multi-class. You only belong into one class, not both, right? And then you have multi-label. So multi-label would be things like maybe these athletes, can run, can swim, can cycle. So you may have a male athlete who can cycle, swim, and run. You can join a triathlon, right? Or you can have a female athlete who can only swim, right? He doesn't do other sports, right? So you have multi-class, multi-label, and you can bring in the different activation function to help you with the multi-class, multi-label in the algorithm. And then prediction. Now, prediction is something that typically I see that happening at the end of the classification, and you can look at the result to give you a probability and a prediction, and take action based on that. And as far as the Oracle machine learning is concerned, we have the whole set of supervised learning algorithm that you can choose from: decision tree, naive Bayes, or whatever, which I talked about earlier. So you can pick and choose and select, the algorithm that is most suitable for your needs. And then, so apart from the classification, you have regression, right? That's, I also explained that before. That's the regression between two variables, dependent, independent, right? And then you have anomaly detection, which I talked about. And then for the unsupervised learning, which I also explained along the way, you have about what it is and so on. So you have the clustering, and you have the association rules for the unsupervised learning. I also like to mention this in passing because this is super interesting, and to me, this is one of the scariest aspect of AI, where machines can become much more intelligent than humans. So over here we have two agents, the blue agent and the red agent, and they are deployed over here, and they learn as they go. So these agents go through many iterations, and then they learn and they become more and more clever. I mean, they become more and more clever in dealing with each other. So the red agents are trying to catch the blue agent, and the blue agent, will learn to devise strategies to block the red agents from coming in, and the red agents will devise strategies to find ways to get into the room and to catch the blue agent. And after many iterations, they try to outsmart each other, and they become extremely intelligent. So that's machine learning, reinforcement learning, which I talked about earlier, about the agent taking actions, going from state to state in an environment, right, and receiving a reward for every action that it takes. Imitation learning. So this is the drone that is trained in simulation, and then it gets to fly in real life on its own. Right? The algorithm is it gets trained in a simulation environment. Then what I did was to deploy this algorithm in real life on a real drone, and it flies on its own through this red rectangles that it can recognize and fly through them. Right? So there are some use cases which can be used for this. The other one is gesture recognition. So this is also becoming quite popular nowadays, where you can recognize hand gestures or whatever, and then do something based on what you see or recognize. And then the next one, which is autonomous robotics. So this, as I said before, is an amalgamation of all the different capabilities of AI all coming together. You have computer vision, you have supervised learning, you have reinforcement learning, deep learning, path learning, path planning, right? Collision avoidance, SLAM. SLAM stands for simultaneous localization and mapping, right? So as you move along, you do your localization and do a mapping on the fly, right? So this is very useful in unknown terrains and so on. And then you have mobility, and working in tandem with all this technology and the result is what you see on the screen, all these different possibilities. So lastly, I just want to conclude and summarize that, a smart city solution usually comprise the various layers involving the devices, the computing platforms, the algorithms supported by the database and analytics, as well as the front-end applications in the form of a chatbot, mobile app, web browser, etc. And the framework brings about a connection, right, between the environment and the computing platform. And this connection enables the computer to learn about the environment and to make decisions and to take actions, right? And to interact with the users. And so this enables us to come up with use cases to solve problems, right, in our smart cities. So that's all I have. I'm sorry I exceeded the time by 2 minutes. I'll hand it back to Suyan. Thank you. Suyan?
Yes, sorry. Yeah.
Sorry, I was thinking